we're recording now. All right. So this is where we last left off. So I was, Gregory and we did a couple of videos together on the wave interference thing, but there was a fair amount of math, so we didn't quite get all the way through it. Gregory's busy working on his laser stuff, so thank you so much for stepping in, and hopefully we can knock this out. You guys remember Demetrius from Planetoids and Accelerate the Blob and
all those fun videos.
Yeah, how's the semester going for you?
It's pretty exciting, you know.
Yeah.
Research, schoolwork.
Yeah. What courses are you taking?
Just astronomy, physics, differential equations. Yeah.
Nice.
Very, very fun.
Keeping you busy there.
A little bit.
Yeah.
Yeah. So
this equation is where we last left off with the wave interference activity. So we decided that if, you know, so we have these two speakers and we have some microphone at the position x, y, and if the following is true about the position of those microphones, if, you know, the distance between that microphone and speaker 1 minus the distance between that microphone and speaker 2, if the difference between those adds up to n times the wavelength of the sound divided by 2, if it equals to that, where n equals 135, then you will have destructive interference and you won't hear anything at that location.
Okay.
Okay? Here's the next part of the challenge, all right? And now all we have to do is to figure out what is y as a function of x. What is that? So just let's look at this expression for a second. How are we gonna? How would you even start it? What do you think?
Square both sides, I guess, or.
Yeah, we can square both sides, but here's the thing, though. You can square this and get rid of the square root. You can square that and get rid of the square root, but then you have this cross term. You have to multiply this by that, and then you still have square roots in there, so you're not going to be able to cleanly get out.
No, it's going to be tough.
Yeah, so that's not going to go anywhere. I'll spare you the details.
Okay.
It's just not going to work at all. Okay? Well, what we can do is we can use an approximation.
Okay.
And so we're going to come up with an approximate formula for y as a function of x.
Okay.
So it's not going to be perfect.
It's going to be close.
But, we'll find out, right? We'll come up with something, and then when we get it, we'll put it in the code, and we'll see if it matches up with the actual code. Again, because the code, you can see where the lines of destructive interference are. So I'm going to go ahead and erase this. I'm going to give you the coveted marker. And what we're going to do, here's what we're going to do. So we're going to take just that part, and let's rewrite it as the square root of a plus b.
Okay.
Okay? So you can go ahead and do that. I'm going to erase that for you. And a is clearly x plus d squared, and b is going to be equal to y squared. And so before we get to the approximation part, let's go ahead and factor out the b. And the idea here is we're going to use an approximation if b is much larger than a. Okay? And so what that means is that if y squared is much larger than x plus d squared, which is kind of like saying if y is much greater than x. And so this approximation we're going to do is only going to work in certain parts of that plot. So there we go. So you factored out the b. Yep. That looks good. And now let's think about this term. Can we approximate this for the case that if b is greater than a? Do you know the formula?
Yes, I do.
Very good.
Using the bacon symbol.
The bacon symbol. This is one of my favorite symbols. So it's a bacon symbol. I mean, technically, I don't know, what would you call it? Like approximating something?
Yeah.
Approximately equals to is probably...
Closest.
What?
The closest symbol?
Ish.
Yeah.
Ish. You know. The drunk equals sign. That's another good one. But the idea is that this is approximately, it's roughly equal to that. Yeah. So there we go. And, earlier we did, we actually put this in a calculator to see if it worked. Remember?
Yeah. We use b equal 3 and a equal 1.
Right, so if b equals 3, that's much bigger than 1.
Mm-hmm.
You know, not a ton bigger, but big enough, right?
Mm-hmm.
And so we ran that in the calculator, and we said, okay, well, a over b, so if this would be 1/3 plus 1, that's 4/3. Square root of 4/3, you put that in the calculator. And then we did this, okay, 1 plus 1/2 plus 1 over 3, that's 1/6, so that's 1 and 1/6. So you end up getting 5/6 here. Or sorry, that would be 7/6 here, right?
Yeah.
Okay, 7/6 ends up being, if you put it in a calculator, it actually ends up being pretty close to the square root of 4 over 3.
Yeah.
So it actually works out pretty well. And you guys at home, you can try it, put in different values for A and B, and see what you get. It's just a fun thing. Try it out here, and it just works. Okay? So now we're going to use this on this.
Okay.
So go ahead and have at it.
Okay. So let's start.
So you factored out y squared, right?
Yeah.
So keep doing what you're doing. That's right. So this is going to be approximately equal to that, right? So b is equal to y squared, so the square root of y squared is y. That's why you have the y there, right?
Mm-hmm.
And then you're going to have 1 over here because there's a 1 over here, right? Because you factored out. And this is a over b.
Right.
And then should be a squared there, 2y squared, right?
Yeah.
Right? Because b is y squared. Okay? So we got this. Why don't we go ahead and just erase that real quick? Just because it's kind of getting in the way. I don't know if you want to write it over here.
Yeah, let's write it over here.
Let's do that. But that looks pretty good. And then the next thing we're going to do is we're going to use that same approximation on this side. In a minute after you rewrite that. And then you probably want to take the quantity times square root of b there too, right? Because that's... Yeah. There you go. So we'll just leave that up there. So go ahead and do the same approach with this one. The only difference is that there's going to be a minus sign out front, right?
Mm-hmm.
And then there's just going to be the x minus d there. So you're going to factor out the y. That's great. The square root of y squared is y. And yeah, so this minus this, and this all equals n lambda over 2. But we'll just take a break on that real quick because we can save the space. I don't know if you want to or want to do it below. Yeah, go ahead and write that there. So and then we'll just write it below the next part. So the next thing we're going to do is we're going to multiply through by the y because I don't know. Let's look at this for a second. Do you think there's going to be some cancellations? Do you see anything that might work?
The ones will cancel.
Yeah, so let's multiply through by the y and see what cancels out. Yeah, so instead of having 2y squared on the bottom, we'll just have y over y squared is y. Y times 1 is y. Same thing over here. And there you go, minus the y. Cut yourself there. A second. Great. All right. So now is there cancellation. Now it's even easier to see.
Yeah,
right?
it is.
So the two y's are going to cancel. Go ahead and slash those out. All right. And then now what should we do?
Let's go ahead and...
Looks good to me.
all over 2y.
There you go.
And then
And lambda
over 2.
over 2. All right, I'm going to give you a break. I'm going to go ahead and do the next part. So I don't know if you guys can look at this here and notice there might be some cancellations, but I'm going to go ahead and multiply that out. Right, so I'm going to do it over here. And x plus d squared is going to be equal to this. 2xd. Have you gone to any of the games lately? By the way, at OSU? Did you get
Oh.
tickets?
No, not lately, but
No.
I did enjoy watching the Super Bowl.
Yeah, you did?
Oh my God, it was the greatest game ever.
That's
was
cool.
Awesome.
I went to the OSU men's basketball game the other day.
Oh, you did?
Yeah, we got
Oh, wow.
tickets. That was fun.
I've been there. I went to one game, basketball game. It was really, really nice.
Yeah.
Very, very exciting atmosphere.
So here's what we're going to do. So we've got, I worked it out. X times X is X squared. D times D is D squared. X times D plus D times X gives you 2XD. And we got this down here, but here's the thing is that we're subtracting the two. So I'm going to minus sign there. And X squared plus X squared is 0, right? Sorry, X squared minus X squared is 0. D squared minus D squared is 0. But, here we go. Here's the beauty of the whole thing. 2XD minus negative 2XD.
Gives you a 4XD.
4XD, there you go. 4XD. Alright? And so this whole thing we can rewrite as 4XD over 2Y equals n lambda over 2. Boom. Way simpler.
Woo! Yes.
Way simpler than what we started with, right?
Right.
So what should I do next to try to simplify this further? I don't know, you want to try it?
Yeah. So, anytime. Cross multiply and divide. So
So go ahead and multiply both sides by y then. And so then the y will cancel from here. So that sounds good.
and we should divide.
Cancel that one out too. Multiply both sides by 2, so you get those 2's to go away. Yep. 2, that works for me. Yep. And
Divide by
the n lambda there, right? I know this is kind of a mess to watch, but it's just want to make sure you guys can see all the steps. And
Yeah.
so now we have the only thing left over here now is y, right?
yes.
So y equals, what do we got?
We got the 4XD
4xd
over the n lambda.
Boom, we did it.
Woo!
Ha! Finally. Now, here's one thing. There's one more thing we can do. We can rewrite this. See, 4d and lambda, those are all constants, right? Because
Right.
that's just the distance between the speakers to the origin is d, and the wavelength of the sound is just lambda. It's not, so let's rewrite this, all that times x. And the question is, why is it important that we rewrite those things times x? Obviously, it's exactly the same equation, but why would it make, why is it important to write it that way?
Well, you can see that it's a straight line. You can see that the 4D over n lambda is just a constant.
Yeah, that's right. So if you imagine that we were going to come up with some sort of y equals mx plus b, well, we now know that, well, b is 0, and m, the slope, is just going to be 4d over n lambda. So let's take this result and put it into the computer program and see, does it even line up with the lines of destructive interference?
Yeah.
Right?
Yeah.
All right, well, let's try it out. And maybe it'll match up really well, or maybe it won't, because we used an approximation here, right?
Right.
So the only way that we're going to know if this matches up is if we actually go and put it into the code.
Right.
So let's
Come back
do
with
it.
part 5, and you will see the magic that we created on the board.